Hello and welcome to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on 2's complement binary. 2's complement is a method we can use to represent negative numbers in binary. It works by making the most significant bit negative. The most significant bit is the bit in the column with the largest heading. The largest number we can make with 2's complement binary using 8 bits is 127 by putting a 1 in all of the positive columns. On the other hand, the smallest number we can make is minus 128. We do this by just putting a 1 in the single column with the most significant bit, which is negative. For all numbers that were between minus 128 and 0, we would start by putting a 1 in this column and then adding back the numbers to get to the value we need. Let's have a look at an example of converting the number negative 82 to 2's complement binary. We know that if it's negative, the first digit is going to be a 1, and we're going to start at minus 128. So we need to work out how much we're going to add back. So if minus 128 plus something is equal to minus 82, then that something is equal to minus 82 plus 128. Which is 46. Now that we have our number to add back, we can complete this just like a normal denary to binary problem. Put a 1 in the column with the largest column heading that is not bigger than our number, and place 0 in any columns that you go past. So in this case, we go past 64, and then 32 is the column where we're going to place a 1. From here, we calculate the new remainder. We had 46 we were looking to add. We've put in 32, so we have 14 remaining. We now look for the next column heading that's not bigger than our remaining number. So that's 8. We put a 0 in the 16s column because we went past it, and a 1 in the 8s. The new remainder is 14 minus 8 is going to be equal to 6. So we put a 1 in the 4s column, then we're going to put a 1 in the 2s column. We've got nothing remaining. That is our number. As you can see, 10101110 in 2's complement binary with 8 bits is equal to minus 82. And you can check this because minus 128 plus 32 is minus 96, plus another 8 is minus 88, plus 4 is minus 84, plus another 2 is minus 82. So we do come to the right number. The flip the bits method is another way to get the correct representation for a negative number in 2's complement binary. To do this, we first represent the number as its positive equivalent. We then flip all the bits, meaning if it's a 0 it becomes a 1, if it's a 1 it becomes a 0, and then we add 1 to the rightmost column. Let's use minus 82 for an example again. So we start by creating positive 82, which is 0, 1, 0, 1, 0, 0, 1, 0. Now we're going to flip all the bits. So the 0s become 1s, the 1s become 0s, and we've got 1, 0, 1, 0, 1, 1, 0, 1, which would actually be minus 83. Now we add 1 to the rightmost column, which was a 1, so it's going to become a 0, and that's going to move to the next column. That was a 0, so it becomes a 1. Our new number is 1, 0, 1, 0, 1, 1, 1, 0, which is minus 82, and you can compare it to the last number we created and see that it's exactly the same. That brings us to the end of this video on 2's complement binary. Join me in the next video when I'll be looking at fixed point binary. Use the resources at MrGoff.com to help you revise computer science, and until next time, it's bye for now.